This is Unit 2, Segments, Lines, and Angles, Preview Video 2.6, Angle Bisector, and Congruent Angles. Sit tall, ready, inhale. Hold your breath. Birthday candle. Taking a look here, don't forget your parent's signature. All right, students, this page you're doing on your own. Pause the video, restart when you're done. Welcome back. Hopefully you have a red pen. I'll be looking for corrections here. Corrections, not copying, folks. There's a difference. Corrections, not copying. I'm going to move kind of fast. It says JKL and LKM are a linear pair. Okay, and here K has to be the middle, and L is the common. So share a spine, make a line. J, K, L, L, K, M. And you were told that J, K, L, that's 5x, and LKM is 14x minus 10. Find everything possible. Linear pair, share a spine, make a line, which means you add up to 180. So you should have here done 5x plus 14x minus 10 equals 180. That's 19x equals 190, x equals 10, which makes this 50 degrees. And this is going to be 130. Correct your work. So today we're going to be talking about congruent angles. Under what circumstances do you have congruent angles? Let's recap the kinds of angles that we studied last class. So first we talked about adjacent angles. Adjacent angles are any two angles that share a spine. Any two angles that are back to back to each other. Complementary and adjacent. Complementary means adds up to, complementary adds up to 90 degrees. Two angles that add up to 90 degrees, which these two do, and they're adjacent in this case, which means back to back. Vertical angles, always congruent. Opposite angles, always congruent, like a bow tie. And linear pair, share a spine, make a line. So these two angles here and here, they share a common spine and they make a line, which means they add up to 180. Those are the relational angles we talked about last class. So both times here, I'm talking about the angle PQR. So we have the Q as the vertex. And in this case, we have an interior ray QT. Interior just means somewhere inside the angle, but not in the middle. So this blue angle QT is interior, meaning somewhere in the mouth of the angle. This is a bisector. Bisector means to cut right through the middle. So the bisector is going to go right through the middle, QT. And if it's a bisector, you have to have sweep, hatch, sweep, hatch. This is a bisector. I'd like you to attempt just to draw these sentences. Just draw. Pause the video. Welcome back. Hopefully you're correcting and not copying. So one step at a time here. It says draw an obtuse angle, HIJ. So obtuse means bigger than 90 degrees. If you flipped yours the other way, upwards, that's totally fine, or sideways. It doesn't matter as long as it's obtuse. With a bisector of IK. Hatch mark, hatch mark. Trace and sweep HIK. HIK, trace and sweep. Says draw a bisector of HIK, so that yellow angle IL, we are cutting directly in half. That's a bisector. And you should have 2 hatch marks for IL. Why? Because it is your second bisector. Correct your work, please. So you have 2 different scenarios if you have an adjacent angle. If you have 2 angles that are adjacent back to back, but you don't have a bisector, what's true is little angle plus little angle equals the big angle. Little angle plus little angle equals the big angle. When you have a bisector, that means these 2 angles are of equal measure. So your equation using a bisector would be angle equals angle. Both of these are adjacent. We're going to do this one together. We're going to draw an angle EFG bisected by FR. It doesn't tell us how big it is. So we're just going to draw it. See what happens. We have a bisector FR, so we have hatch marks. EFG, EFG, trace and sweep, is 15x plus 6. RFG, trace and sweep, is 10x minus 32. Note your congruent marks. Find everything possible. So we have two scenarios. Our two scenarios would be angle equals angle, and angle plus angle equals a bigger angle. So you look at what you have here. Warning, the blue and the green are not equal. What is true is that these two greens add up to the blue. So because of the bisector, so one angle plus another angle equals this big angle, 15x plus 6. Collect like terms. We end up with 5x equals 70. Divided by 5. So we figure out that x is 14. But wait, there's more. It's very important that you get in the habit of finding everything possible. So right here, 10 times 14 is 140. Minus 32 is going to be 108. So obviously, this is two obtuse angles fit together, which is entirely possible. It's just not drawn to scale. And then to check, 15 times 14 that's 210 plus 6 is 216, which if you check, 108 plus 108 does equal 216. Try this one on your own. Pause the video. Alrighty, welcome back, students. Run now, get your red pen. You're correcting. You're not copying. You're correcting, not copying. So we're going to start here by drawing an obtuse angle PIT. So hopefully your PIT is obtuse. And it's being bisected by IM. And we're told that PIM is 6x plus 5. MIT is going to be 4x plus 31. Find everything possible. Your thing equation here is angle equals angle. Should be getting 2x is 36. X equals 18. Then you come over here and you check your work. 6 times 18. That's 108. Plus 5. And then 4 times 18. Whoops, something happened here. Numbers weren't working out. That's why it's always good to check. Hopefully you checked yours. That's a plus 5, 6x plus 5, 4x plus 31. This is 2x, and this is minus 5, both sides. I accidentally plussed it. And that's going to equal 26. X equals 13. That's more like it. So 6 times 13. 78 plus 5, 83. Let's check this. 4 times 13. 52 plus 31. Also 83. There it is. And of course, 83 plus 83 is going to be 166. Now we're going to talk about what makes angles congruent. And we have 5 different things that makes angles congruent. So if angles have equal measure, they're congruent. If I have the measure of angle 1 equals 60, measure of angle 2 equals 60, then we would say angle 1 is congruent to angle 2, equal measure. If 2 angles are right angles, of course, they're also congruent. Makes common sense. They're both 90 degrees. They're both equal measure. If an angle is bisected, then you end up with congruent angles, of course. If angles are vertical, they're always going to be congruent. Watch out for those. Straight lines. Angles are transitive. This would be an example of transitive angles. Let's say I had a scenario. Look, I have vertical angles. And so I could say angle 1 is congruent to angle 2. And then let's say that this was a bisector here. So angle 2 is congruent to angle 3. If this is true, we can connect angle 1 to 3. We can transfer the congruency. Therefore, that means therefore, angle 1 is congruent to angle 3. That's called the transitive property. Let's pull it all together here. A little summary. In the figure below, trace and sweep FCR and PCZ. Just trace it. Trace segment RZ, trace segment FP. FCR and PCZ are vertical angles. Mark appropriately. That would mean this. Trace and sweep ACF. CR. Bisects ACF, so this is true. Mark appropriately. Now I'm going to give you one measurement only. One measurement only. And the measurement I'm going to give you right here is 135 degrees. 135 degrees. Knowing what you've marked on the diagram, I want you to find all possible angles in this diagram with this given information. I'm not going to give you the correct answer. I'm going to check it in class. Find all possible angles given this scenario. Don't forget to summarize the main things that you have learned in this lesson.